Okay, good evening, guys. Today we'll continue with problem solving of limits, continuity, and differentiability questions. Okay. So this is the first question for today. You have 2 minutes to solve the question and let me know the answer. Okay, Nishchay, did you try the question?
Yes, ma'am.
Answer आया?
Is it B?
No, it's not B. Okay, we'll discuss it now. No problem. See, on looking at the options here, one thing is clear that 0 is the key factor. Here 0 is not, here 0 is included, here it is given 0 to infinity, here it is minus infinity to 0, union 0 to infinity. So first, let's check differentiability at the point 0. Okay. So what is differentiability rule? Differentiability rule says that the left hand derivative should be equals to the right hand derivative. So now let's find out the left hand derivative. What is left hand derivative? Limit h tending towards 0. It is f of a minus h minus fa upon minus h. Okay, so in this question, A, we are checking on A. So what this will become? Limit h tending towards 0. F of 0 minus h is minus h minus f0 upon minus h. Now, what is f of minus h here? Fx is x upon 1 plus mod x. We have to find f of minus h. It will be minus h upon 1 plus mod of minus h. Okay, Yash, we are discussing the first question now. This was the question. Okay, so this was the question. Set of points where fx equal to x upon 1 plus mod x is differentiable. So what I'm checking is in the options, this 0 is looking as a key factor, right? So I'm checking the differentiability at 0 and then I'll comment on the question. So what does the differentiability rule says? That left hand derivative should be equal to right hand derivative. So we are checking on a equal to 0. So first we are finding left hand derivative. The left hand derivative is limit h tending towards 0, f of a minus h minus f upon minus h. And now we were finding f of minus h. And what is f0 here? f0 is 0. So now let's put these f of minus h and f0 in the left hand derivative. Moving on to here, it becomes limit h tending towards 0. Kritika, this was the question. Set of points where fx equal to x upon 1 plus mod x is differentiable. I'm checking the differentiability at 0. So f of minus h is minus h upon 1 plus mod of minus h minus 0. No problem, Kritika. Minus 0 upon minus h. So what we are getting here? Limit h tending towards 0 minus h upon minus h into 1 plus mod of minus h. So this becomes limit h tending towards 0, 1 upon 1 plus mod of minus h. We will put h equal to 0. So we get left hand derivative as 1. Now let's check for the right hand derivative. So right hand derivative is limit h tending towards 0, f of a plus h minus fa upon h. Now again we are checking for a equals to 0. So this implies it becomes limit h tending towards 0, fh minus f0 upon h. fx was x upon 1 plus mod x. So fh becomes h upon 1 plus mod h. f0 is 0 here. So if we put it here, we get limit h tending towards 0, h upon 1 plus mod h upon 1 plus mod h minus 0 upon h. So again we are getting what? 1 upon 1 plus mod h. So this becomes 1. When we put h equal to 0, right hand derivative becomes 1. Left hand derivative was 1. Right hand derivative is 1. So at 0, the function is differentiable. as left hand derivative is equal to right hand derivative. So amongst these options, this is not possible. This is not possible because it is differentiable at 0. So both of these are cancelled. Now we have to check for negative value, because if negative values are there, then first can be correct. Otherwise, D will be the option. So now let's check for the negative value. There is no place. So we'll check for any negative value. I'll check for x equal to -1. So at x equal to -1, what will be the left hand derivative? Limit h tending towards 0, f of -1 minus h minus f of -1 upon minus h. So this becomes -1 minus h upon 1 plus mod of -1 minus h minus of f of -1 was -1 upon 1 plus mod of -1 upon minus h. We are checking for left hand derivative. So now this becomes -1 minus h upon 1 plus mod of -1 minus h. H is tending towards 0, so I can directly write it here as 1. And this becomes minus minus plus upon 1 plus 1, 2. So 1 upon 2. And here it is minus h. So this finally comes out to be -1 minus h plus 1 upon 2 into minus h. So this is 1 by 2. Now let's quickly check for right hand derivative at x equal to -1. So right hand derivative at x equal to -1 is limit h tending towards 0, f of -1 plus h minus f of -1 upon h. So this becomes -1 plus h upon 1 plus mod of -1 plus h minus f of -1 is -1 upon 1 plus mod of -1 upon h. So this here becomes -1 plus h upon again 1 plus -1 plus h, h is 0. So this becomes mod of -1 is 1. So this becomes 2 plus 1 by 2 upon h. So this is 1 by 2. Now you can see that left hand derivative at x equal to -1 is equal to right hand derivative at x equal to -1. So the function is differentiable at x equal to -1 as well. So this option gets cancelled and the correct option is A. Any doubts, anyone? Should we move on to the next question? Okay, clear, great. So now This is the next question. The function f, domain is r minus 0 to range r, given by fx equal to 1 upon x plus 2 upon e raised to the power 2x minus 1 can be made continuous at x equal to 0 by defining f0 as what? You have to find f0 की definition. You have 2 minutes to solve this question. Yes, you can apply in hospital if it is possible. But first you have to check the indeterminate form. So now should we discuss the solution? Should we move on to the solution part now? So let's discuss the solution now. We have to make this function continuous at x equal to 0. We have to find the definition of f0. So here we know that f0 can be written as limit x tending towards 0 minus fx, or limit x tending towards 0 plus fx, or limit x tending towards 0 fx. Okay. The solution for this question is D. The answer is 1. Are you guys trying? Okay, Yash. Okay. So let's find out f0. We discussed that it is limit x tending towards 0 fx. So this is limit x tending towards 0. Fx was 1 by x minus 2 upon e raised to the power 2x. Is it minus 1? Okay, minus 1. So now we have to find limit x tending towards 0 of this function. So what I'm going to do is I'm taking LCM. So e raised to the power 2x minus 1 minus 2x upon x into e raised to the power 2x minus 1. Now you can proceed with L hospital, but in last class, one of you told that can we use the expansion? So today we'll try expansion. So e raised to the power x का expansion क्या होता है? 1 plus x square upon 2 factorial plus x cube upon 3 factorial and so on. Then e raised to the power 2x का expansion होगा 1 plus 2x plus 2x whole square upon 2 factorial and so on. 2x cube upon 3 factorial. Okay. So now let's put this value of e raised to the power 2x, this expansion in this function in place of e raised to the power 2x. We'll write this expansion. So what we get is limit x tending towards 0, 1 plus 2x whole square upon 2 factorial plus 2x cube upon 3 factorial minus 1 minus 2x upon denominator is what? Denominator is x, again 1 plus 2x plus 2x square upon 2 factorial plus 2x cube upon 3 factorial and minus 1. So this 1 minus 1 is 0. 2x minus 2x gets cancelled. And here also 1 and 1 gets cancelled. So what do we get finally is 2x whole square upon 2 factorial plus 2x whole cube upon 3 factorial and so on upon we get 2x square plus this becomes 4x cube upon 2 factorial. Now what I can do is I can take out this x square common. So if I take out x square common, what do I get inside is x square 4 upon 2 factorial plus 8x upon 3 factorial and so on, because in every term x will come, x will become 0, so it will get cancelled. And in denominator, it is 2 plus 4x upon 2. So what do we get here? Limit x tending towards 0. X square gets cancelled. Now if I put x equal to 0 here, so what we get, this becomes 0 and all other terms will become 0. This will also become 0. So what I get is 4 upon 2 into 1 upon 2 equals to 1. So what is the value of f0? It is coming out to be 1. So the correct option is D. Everybody understood the solution? Or you have any doubts? Okay, it is clear. Then let's move on. Okay, then let's move on to the next question. This is the next question for the day. Let fx equal to 1 minus tan x upon 4x minus pi. X is obviously not equals to pi by 4. X is element of 0 to pi by 2. If fx is continuous in 0 to pi by 4, then you have to find the value of f of pi by 4. You have 2 minutes. Solve it and let me know the answer. Okay, so who got the answer? Yes, Nishchay, your answer is correct. So should we discuss the solution part now? Okay. So again, we have to find the value of f pi by 4. This is very similar to the previous question. Let's find out. The correct option here is C. So what is f pi by 4? F pi by 4 is limit x tending towards pi by 4 fx. So it is limit x tending towards pi by 4. And what is fx? Fx is 1 minus tan x upon 4x minus pi. It is tan pi by 4 is 1, 4 into pi by 4, pi minus pi, 0, 0 by 0, indeterminate form. So I will apply L'Hospital here. So limit x tending towards pi by 4, 1 minus, okay, it is L'Hospital differentiation. 1 का differentiation is 0, tan x का differentiation is sec square x. In denominator, we get 4. Now at x equal to pi by 4, what is the value of sec x? It is root 2. So we get minus root 2 whole square by 4. So the answer comes out to be minus 1 by
Ma'am,
2. Yes?
isn't L hospital only for when X is tending to 0?
No, you can apply it here also.
Okay, so X can be tending to anything.
Yes, it is valid here.
Okay.
So now the answer is clear. Should we move on to the next question now? Okay. So this is the next question. Let y be an implicit function of x defined by x raised to the power 2x minus 2x raised to the power x cot y minus 1 equal to 0. We have to find the value of y dash 1. You have 2 minutes to solve this question. Who got the answer? No, it is not C. But it's great that you attempted it. So now we should discuss the solution. Before that, Kritika, you asked for this limit. Here, the thing which matters is कि ये indeterminate form में आ रहा है when x is tending towards pi by 4. That is why 1 minus tan pi by 4 is 1 minus 1, 0, and 4x minus pi, 0. So 0 by 0 is indeterminate form. So that is why we can apply L'Hospital here. Function of x defined by x raised to the power 2x minus 2x raised to the power x cot y minus 1 equal to 0. We have to find the value of y dash 1. So before finding anything, what I want to find is y1, because it will make it easier now if I get the value of y1. Okay, so let's find y1. So at x equals to 1, 1 raised to the power 2x becomes 1 minus 2 into 1 is 1 cot y minus 1 equal to 0. So this implies that cot y is 0. This means that y is equal to pi by 2. Okay, so this was the initial thing. Now what I'll do is I'll differentiate this function. What is the function? X raised to the power 2x minus 2x raised to the power x cot y, I think, and minus 1 equal to 0. So we have to differentiate this part here. So for differentiating this, what I'm doing, I'm assuming this equal to 2x and then I'll take log to make it easier. Equal to 2x log x and now I'll differentiate here. So 1 upon y dy by dx equal to 2 log x plus 2x by x. This is in the form u into v. Now what do I get is 2 log x plus 1. But here y is also there. So y 2 log x plus log small x plus 1. Now what was y? Y was x raised to the power 2x. So this becomes 2x raised to the power 2x log x plus 1. So this thing is clear. This first term is differentiated. Now we'll differentiate this second term. Let's write it. 2x raised to the power 2x log x plus 1 plus differentiation of minus 2, this is minus differentiation of 2x raised to the power x cot y एंड ये जो -1 है इसका डिफरेंशिएशन हो जाएगा 0. So we have to differentiate this now. So what do we get here is 2x raised to the power 2x log x plus 1 minus 2 can also be taken outside common. So x raised to the power x का differentiation होता है x raised to the power x log x plus 1. अभी हमने देखा cot y वैसा ही plus x raised to the power x into minus cosec square y cot y का differentiation into dy by dx and this is here equal to 0. So now it was given that we have to find at x equal to 1. So now let's put x equal to 1. So here if I put x equal to 1, I get 2 into 1. Log 1 is 0. Minus 2. This is 1. Log 1 is 0. Into cot y. What was cot y? y was pi by 2. Here we got y as pi by 2. So cot y is 0 plus 1 into minus cosec square y कितना होता है? Minus cosec square pi by 2, which is cosec square pi by 2 is 1, so it becomes minus 1 into y dash 1 equal to 0. This becomes 2 minus 2. This is 0 minus y dash 1 equal to 0. What we get here is 2 plus 2y dash 1 equal to 0. This implies that y dash 1 is minus 1. So the correct option was D. You have any doubts? Is it clear to all, this question? Clear. Okay. Great, Kani. So this is the last question for today. This is a very easy question. You have 1 minute to solve it, and then we'll discuss the solution. Here, guys, this limit x tending towards infinity f 3x upon fx is 1. Right? Let f is from r to r be a positive increasing function with limit x tending towards infinity f of 3x upon fx equal to 1. Then you have to find out limit x tending towards infinity f of 2x upon fx. So should we discuss the solution? Yes, okay. So it is given that f is an increasing function. Okay. So if f is an increasing function, then what it implies is fx is less than equal to f of 2x is less than equal to f of 3x. Okay. And it is also given that it is a positive increasing function. So if fx is positive, I can easily divide fx without any problem in sign. Without reversing the sign, I can divide fx because it is given that fx is a positive increasing function. So now, if I take limit x tending towards infinity in all three, then what do I get is fx upon fx is less than equal to limit x tending towards infinity f of 2x upon fx and less than equal to limit x tending towards infinity f of 3x upon fx. Now this is here 1. This is given as 1. Now can you see that this is sandwiched between limit x tending towards infinity fx upon fx and limit x tending towards infinity f of 3x upon fx? Okay, so we'll apply sandwich theorem here and By sandwich theorem, it implies that limit x tending towards infinity, f of 2x upon fx will also be equal to 1. So the correct option here is A. Everybody understood the solution? Okay. So this was all for today's class. I hope you enjoyed the session and we'll meet on the next lecture. Okay, thank you.